Number 1 asks us to rationalize the denominator. Now, since we have a binomial, two terms being separated by a subtraction sign, what we're going to do is we're going to multiply the top and bottom of this fraction by the conjugate of the denominator. The conjugate just means to change the sign in the middle. So we're going to change that subtraction sign to an addition sign. And then from here, we'll just multiply everything out. All right, so when we start with the top, 2 radical x times 2 radical x. Well, 2 times 2 is 4, and radical x times radical x is just x. And then 2 radical x times 2 would be 4 radical x. So our numerator, we have 4x plus 4 radical x. In the denominator, we're going to have to double distribute. So again, 2 radical x times 2 radical x. Well, 2 times 2 is 4, and radical x times radical x is x. 2 radical x times 2 is 4 radical x. Negative 2 times 2 radical x is negative 4 radical x. And negative 2 times negative 2 is negative 4. Now, the reason we multiply by conjugates in the denominator of the fraction is so that these two middle terms here are going to cancel off. So a positive 4 rad x and a negative 4 radical x are going to cancel off. So at this point, we're left with 4x plus 4 radical x over 4x minus 4. And we always want to simplify our fraction. So, I mean, you can think about it one of two ways. You can either factor a 4 out of the numerator and then factor a 4 out of the denominator. So then that 4 that you factored out on top will cancel off with the 4 that you factored out on bottom. Or if you just look at all of your terms individually, as long as there's a number that divides evenly into every single term that we have here, you can divide by that number. So since everything divides by 4, I'm going to do that. So 4x divided by 4 is x. 4 rad x divided by 4 is just radical x. Again, 4x divided by 4 is x. And then 4 divided by 4 is 1. So we're left with x plus radical x over x minus 1. Okay, number 2 just wants us to simplify. Now here we're taking a look at the 5th root. So first thing you may want to do is just off to the side, you might want to list out all of your perfect fifths. Okay, let's start with our numbers. So 1 to the 5th, 1 times 1 times 1 times 1 times 1 is 1. 2 to the 5th is 32. 3 to the 5th is 243. I'm not going to put too many more. Let's just do one more. 4 to the 5th is 1,024, which is already bigger than the number under our radical here. So it lets us know that, we can stop. I'll just put a dot, 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 so we know the list keeps going. Okay, so now let's list out our variables. Well, as long as the exponent is a multiple of 5, it's a perfect fifth. So we would have x to the 5th, x to the 10th, x to the 15th, x to the 20th, and so on. We'll just put dot, dot, dot. All right, so if we look back at our radical here, we could see that everything under the radical is not a perfect fifth. So what we have to do when that happens is we want to break this up into 2 separate radicals. The first one represents where we're going to put all of our perfect fifths, and the second radical just represents all of our leftover values. All right, so first thing we want to do is we want to take a look at the 486, and since that's not on our list here of perfect fifths, we want to come up with 2 numbers that multiply to 486, where one of them is a perfect fifth. So 243 times 2. So since the 243 is the perfect fifth, I'll put that under the first radical, and the 2 would go under our leftovers. All right, so now 8 to the 10th. Well, 10, the exponent, is a multiple of 5, so that is a perfect fifth. So I'm going to put that entire thing under our first radical. If we look at our b to the 14th, 14 is not a perfect fifth, so we want to take out the biggest perfect fifth possible. So the biggest multiple of 5 that's less than 14 would be 10. So I'm going to take out b to the 10th, and that's going to leave me with 4 b's in my leftover radical. And then c is not a perfect fifth. Unfortunately, we can't take any perfect fifths out of that, so I'm just going to put that in my non-perfect fifth radical, in my leftovers. So now if we were to take the fifth root of 243, that's 3. The fifth root of 8 to the 10th is just a squared. All you have to do is just take the exponent of 10 and divide it by the root of 5. So 10 divided by 5 is 2, so that would give you a to the second, or a squared. Same thing with the b. We'll have b squared, and then all you have to, that's supposed to be a 2, and then all you have to do is just bring down the leftover terms under the radical. So this would be our final answer. Number 3 asks us to solve for x. Our first step is to isolate one of the radicals by itself on either side of the equation. So I'm just going to subtract the radical x minus 3 from both sides. And by doing so, I'm left with the radical x plus 2 all by itself on one side of the equation. Now, once you've isolated one of the radicals, all you have to do to get rid of the radical is to square it. But if you square the left-hand side of the equation, you also have to square the right-hand side of the equation to keep it equivalent. So what happens is a square and a square root cancel each other out. So on the left-hand side, we're left with x plus 2. And then on the right-hand side, since we have a binomial being squared, we're going to have to write that out twice and then double distribute. Okay, so let's bring down the x plus 2. And when we double distribute, 5 times 5 is 25. 5 times negative radical x minus 3 is negative 5 rad x minus 3. Negative radical x minus 3 times 5 is again another negative 5 radical x minus 3. And negative radical x minus 3 times negative radical x minus 3 is positive, and then just x minus 3. Okay, the radicals cancel each other out. All right, so we still have radicals on the right-hand side of the equation. So even though we're able to get rid of the radical on top of the x plus 2 from the beginning, we still need to isolate the radical x minus 3, and then we'll have to square that again. All right, so in order to do that, we want to get basically these radical x minus 3's by themselves. So let's first combine them. If you combine negative 5 rad x minus 3 and negative 5 rad x minus 3, it's going to give you negative 10 rad x minus 3. And let's just combine our other like terms on this side of the equation. So if you combine the 25 minus 3, that'll give you 22. I'll just put that right here. And then this positive x that we have right here, I'm just going to bring that right down. And let's bring down the left-hand side of the equation. All right, so we want to move everything over to the left-hand side of the equation other than the radical x minus 3. So in order to do that, I'm going to subtract this x and subtract this 22. So minus x minus 22. And what happens is, on the right, these are going to cancel, so we're left with negative 10 radical x minus 3. And then on the left-hand side, the x's actually cancel, and 2 minus 22 is negative 20. So let's get rid of that negative 10 in front of the radical, so we'll just divide, leaving us with 2 equals radical x minus 3. So now that we isolated the radical x minus 3, to get rid of the radical, let's just square it. And to keep the equation equivalent, we also have to square the left-hand side. So that leaves us with 4 equals, well again, since a square root and a square cancel each other out, we're just left with an x minus 3 on the right-hand side. To get x by itself, just add 3. All right, so it leaves us with x is equal to 7. Now remember, with radical equations, you have to check. So I'm just going to do that off to the side over here. And always check in the original equation. So let's just replace the 7 with wherever we see x's in the original equation. So instead of radical x plus 2, we'll have radical 7 plus 2. And then plus radical 7 minus 3. And we want to know, does that equal 5? All right, well, under the first radical, 7 plus 2 is 9, so we have radical 9. And then 7 minus 3 is 4, so we have radical 4 equals 5. And the square root of 9 is 3. The square root of 4 is 2. And since 3 plus 2 does equal 5, this checks out. So what that means is x equals 7 is our solution. Now, I just want to point out, if this was a multiple choice question, rather than doing all of this work, since you have to check anyway, you might as well just take the answer choices that are given to you and plug them back in to the question, plug them back into the equation to see which of the answer choices check out. Okay, so you could just go through the answer choices one by one and see what checks. You do not have to do all of this work for multiple choice. In number 4, we have to factor completely. Now, since we start off with 4 terms, we're going to do factor by grouping. You first want to look at all the 4 terms and say, well, is there anything I could factor out of all 4 of these terms? No, there's not. So what we're going to do is we're just going to jump right into grouping. We're going to group together the first 2 and group together the last 2. Out of the first 2 terms, you could factor out a 3 and an x. And when you do, that's going to leave you with 2y minus 5a. Okay, and the next 2 terms, the only thing you could factor out is an a. Please make sure you put plus in front of the a. And in parentheses, that also leaves you with, excuse me, a 2y minus 5a. Okay, awesome. Well, since our parentheses matched up, 2y minus 5a and 2y minus 5a, one of our factors is going to be 2y minus 5a. And the other factor is going to be what we have on the outside of the parentheses here, the 3x plus a. Okay, number 5 asks us to write the equation of a circle whose center is at -3, 1, and whose radius is 9. Okay, well, keep in mind that the formula for any circle, this is the generic formula, for any circle whose center is at HK and whose radius is R, is going to be x minus h squared plus y minus k squared equals r squared. So this is just, the general formula. Now let's take our specific numbers given to us here. Since the center is -3, +1, we could take that -3 and replace it in place of h here, and we could take the +1 and replace it for the k here. So what we're going to have is, instead of x minus h, we're going to have x minus -3. Well, minus -3 becomes a +3. So then we'll square that. And then plus, instead of y minus k, we're going to have y minus 1 squared. And then equals, well, since our radius is 9, when we square that, 9 squared is 81. So this is the equation of our circle.